Okay, all right. So let us begin today's session. I am Sahil Gaurav from IIT Guwahati. So in this series of session, we are going to solve the previous GATE problem. So that will be useful for your the upcoming GATE exam 2024. So first, I just want to know that uh, currently means you are in which year. Just introduce yourself, year and the college in which you are studying. Someone can just unmute yourself and can tell.
Yes, sir. Very good afternoon, sir.
Good afternoon.
Sir, I am Deepak Kumar, and sir, I am doing BTech, and now I am in third year, fifth sem,
Okay,
and I am preparing for GATE 2024 and 2025.
okay, you are in third year, right?
Yes, sir.
Yeah. Okay, all right. And any other one?
Sir,
Vignesh? Yes, Vignesh.
yeah, I am working professional, trying for grade 2024. I completed my degree in 2022.
Okay, all right. Nice. So have you attempted before this?
Yeah, yeah, I attempted the gate 2024 too. I secured 25 marks in that.
Okay, no problem. So in this series of session in the upcoming 2 months, what what we are going to do? We are going to solve the previous year GATE problems for power system, in which we will discuss the how to attempt the problems and some tricks, some concepts we will also get through. And in between that, if you face any problem, just ask me. And I have also mentioned my email ID. So if you want to just if you wanted me to discuss any special question in the upcoming test in the upcoming session, so you just mail me. And if you have any further, if you have any clarification or doubts that you want personally to be discussed, so that will also give provide some, because in this session we are focused on the solving the problems, how to approach the gate problems.
Yes, sir.
Yeah. So this is my email ID, sahilgaurav at the rate iitg.ac.in. You can contact me if you have any means like personal doubts or something that you wanted me to discuss in the session, upcoming session, because here I will whatever the question I feel important, that is important for your preparation, that I will discuss here. And if you think that it should be discussed in the session, then you just mail me on this ID.
Yes, sir. Sure, sir.
Yeah,
Sir,
yes.
will you upload this recorded session on YouTube?
uh, on YouTube, might not be, but I think that portal is there, na, NPTEL Gate. You can get it from there. That will be definitely, you can find it there.
Okay, sir.
So first I like, oh God. So according to my point of view, the things that are important for GATE exam, the most important things like things important for our GATE preparation is that, so you think that what is the most important point for our GATE preparation? Anyone can tell? So first priority should be your test series. Whatever you have studied and whatever means how many times you studied yourself or in coaching wherever, but you have not approached, but you have not given test series, then there is no point of view that you will score well in the exam. So test series is very much important. And now I think it is going on August. So by this end of August or September, you all must have one test series or two test series that. But every student has to just attempt all the test series for one means whatever test series you have taken. But one test series you have to complete. And next test series you will get the confidence and you will get how to means manage the time. That is very important. Another thing that if you have analyzed the previous year papers and analyze and solve means all the previous year get papers at least after 2010 or 2012 means gate questions you know how to solve with this how to approach that. So we are here focused on this part. At least by this uh, approach, by this initiative we can having all the solution for the gate previous year gate papers. And these things are according to my point of view very important. And the materials you can refer this NPTEL course like Dr. Devpriya Das power system. And if you see in the power system, the most important thing that this question are easy. And if you think means like other parts in other sections, it is like that in signal system or machines. You feel like that it can be solvable, but you may struggle. But in power system, before attempting any question, you can see that means what type problem is. Like you can easily get the answer or not. Means before attempting the question, you are already knowing that. So that is the beauty of power system. I- And if you see our course, this power system, means if you are going to study any power system book, you feel like that this is very vast. But in GATE exam, you feel like that, especially this some topics are concerned. Means some topics are only concerned in GATE exam. Not all this like there are many derivations, there are many means concepts, theories before you can find in textbooks. So in GATE, I can say we can say that power system questions are easy and identifiable. Means what type of question it is, and you can approach that question or not. So in
Sir, this course is available by Dr. Priya Das on NPTEL.
yeah, power system. I think I will just refer in the means upcoming session. Means I forget the means name of this course, but power system it is related to power system. Let me see. 1 minute. I think I have noted down somewhere. Introduction to power system is something you can find on NPTEL. This is available, no problem. And you can refer anyone NPTEL course. There are so many courses on power systems. 2 or 3 courses, I think you can easily get that. So let us begin this session by solving the first problem. And what we are going to do, I am giving you 1 minute, and after 1 minute, I will start to solve the problem. And if you are getting the answer for this problem, then you can type it on the chat box so that we can see that how many are approaching and how many are getting the correct answer. And after 1 minute, I will also solve problem. So the first problem is that a three-phase load is connected to a three-phase balance supply as shown in this figure. If Vn is 100 at the angle of 0 degree volt, Vvn is 100 at the angle of minus 120 degree volt, and Vcn is 100 at the angle of minus 240 degree volt. And the angles are considered positive in the anti-clockwise direction. The value of R for zero current in the neutral wires is. So if anyone is getting the answer, you can type your answer in the chat box. And this first problem is belongs to GATE 2018. So what we have, sorry, we have given VAN 100 at the angle of 0 degree volt, VVN is 100 at the angle of minus 120 degree volt, VCN is 100 at the angle of 120 degree or minus 240 degree volt. So here it is clearly mentioned that for in the neutral wire, just apply KCL at this node, this neutral node, and then we will get neutral current will be IAN. IN is IA plus IB plus IC. So IA will be VAN divided by R plus VVN divided by J10 plus VCN divided by minus J10. So it is given that neutral current flowing through neutral wire is 0. So it is 0. So we just put all these values and we will get the answer for the value of R. So 100 at the angle of R plus divided by R, 100 minus 120 degree divided by J10 plus 100 120 degree divided by minus J10 equal to 0. So 100, it will come out as 10 at the angle of minus J will be at the angle of 90 degrees, so it will be minus 210 degree plus, you can here write minus 10 90, so 10 at the angle of 30 degrees equal to 0. So we just take common 10, and then you are having 10 divided by r equal to 1 angle 30 minus 4 minus 120 minus 210 degree you can write plus 150 degree. I am I have not got any response. So this is very easy problem. I think you are able to solve this problem. So in the session you just prepare with your pen, paper and calculator, and use the just hands on the gate calculator, not this scientific calculator. Always use the gate calculator because you have to face in the exam with the gate calculator only. Now this scientific calculator. In scientific calculator you can easily from this expression you can find the value of r. But for gate you need to more simplify this. So anyone got the value of r?
Sir, that is not 150. This angle. This is
Yeah,
one.
minus 210. So 360 minus 210 will be 150 degree. If you go by this anti-clockwise direction, that will the same meaning. So that's why I put this means it is simply like minus you write minus 90 degree or plus 270 degree like that only. How we have written here this VCN is 100 at the angle of 120 degree. You can also write 100 at the angle of minus 240 degree volt. So that I just express in this way.
uh,
Yeah, 5.7. So beginners, yes, beginners, you are correct. 10 divided by r is equal to, you just simplify this, then cos 30 plus j sin 30 minus cos 150 degree minus j sin 150 degree. So after getting all the answers, after putting all these values, you will get r is equal to 10 divided by root 3. So it will be 5.77 ohm. Now let us see the next problem. So the correct answer for this question first is 5.77 ohm. So the next problem is that for the balanced star-star connected three-phase circuit shown in the figure below, the line-to-line voltage is 208 volt RMS and total power absorbed by the load is 432 watt at a power factor of 0.6 leading. The approximate value of impedance is, and this problem is from GATE 2017. In our session, we will mostly focus on the 2 marks question. I think if you are able to solve 2 marks question, then you can easily crack this first 1 mark question. And if you feel like that, if you have doubt, then you can If you can mail me or you can ask, that is that it should be discussed.
Sir, in this question, this power being absorbed by all the loads or only one loads?
Power jet by all loads. This is three-phase system now, so it is always assume that three-phase means all loads.
Okay, sir.
This is three-phase power. So here uh, we are having 208 volt RMS. Actually, line to line voltage mentioned, but whenever in the problem, if it is not mentioned, then you assume that it is line to line voltage by default. This is the conventional thing that we always assume the data for voltage, always assume as line to line voltage or line voltage. So first convert it into phase voltage, then it will come VAN 208 divided by root 3 at the assume this A phase voltage at the reference, then 120 degree at the angle of 0 degree volt. VVN is 120 at the angle of minus 120 degree volt. VCN is 120 at the angle of 120 degree volt. And this you can analyze from the data. Now we are having three phase power given at 432 watt. So power B, how we write for three phase system? 3 B phase I phase cos phi. Don't need to write I phase. 3 V phase I into cos phi. So if you write it into line to line voltage, then root 3 times line to line V I cos phi. So either expression you can use. Power is given as 432 root 3 into 208 into I cos phi. Cos phi is 0.6 leading. So cos 0.6 leading. So I will be 2 ampere. So this is the magnitude we got. If you want to write in this phasor form, then how can we write? So we have assumed this phase voltage as the reference. So for this phase A current, we can write IA will be, it is zero point 0.6 leading. So cos phi is 0.6, then phi will be 53.13 degree. So IA will be 2 at the angle of 50. It is leading by this voltage 2 at the angle of 53.13 degree. So now it is very simple one. You just write this for per phase system. IA is equal to VAN divided by Z, then Z will be 120 at the angle of 0 degree, and IA will be 2 at the angle of 53.13 degree. So Z value will come as 60 at the angle of minus 53.13 ohm. So correct answer for this problem is C. So how many of you got this answer C? And if you face any problem, any doubt in this solving the problem, you can ask. Yes, Deepak is correct. You can also write the option. No need to write whole. If option is given, then you can write this. If NAT type question, then you can write full.
Sir, for leading power factor, we have to write down positive angle like
Yes,
plus 53.13.
yeah, and means for this, yeah, because leading power factor means fast. Current is leading to the voltage, and if you write this power expression, don't forget to just include the conjugate part, like S is equal to 3 VI conjugate, because for leading power factor we are getting negative reactive powers. That's why we just add this conjugate part in the power equation. So always remember, means many, so always people get this mistake. They don't indulge this negative part. For leading power factor means current will lead the voltage, but we are getting negative reactive power. So that's why to compensate this, we add conjugate here. And for lagging reactive power factor, current is lagging the voltage, and we are getting positive reactive power. So that is the point.
Okay. And sir, I conjugate means we have to change the sign of angle.
Yeah, I understand the sign of angle. So that then you only got negative reactive power. So means like Q will be positive for leading reactive power, for leading power factor, and Q will be negative. Sorry, Q will be positive for lagging, negative for leading power factor. And these are things for the load only, not for source. So source it will change, and for means depending on the loads. So we will go in deep of if we solve that type of problem. But just right now, for loads, Q will be positive for lagging power factor, Q will be negative for leading power. But that's why in power factor compensation, you see that the reactive power for compensating part always comes as negative. QC always will be written negative because that capacitor gives the leading reactive current. So let us see the next problem, question number 3.
Long.
So in this problem, this is also a simple one, but you need to know the inductance expression. Consider an overhead transmission line with three-phase 50 Hz balance system with conductors located at the vertices of an equilateral triangle of length DAB is equal to DBC is equal to DC is equal to 1 meter as shown in this figure. The resistance of the conductors are neglected. The geometric mean radius of each conductor is 0.01 meter. Neglecting the effect of ground, the magnitude of positive sequence reactance is given in per kilometer, rounded up to 3 decimal places. You have to here in this question it is asked about the magnitude of positive sequence reactance in ohm per kilometer. So just you need to take care of these units. It's always take care of unit in NAT type question. Means if you have calculated in milli ohm per kilometer and you type that answer, it will be wrong. So just take care of the unit.
Sir, firstly we have to calculate here inductance, right?
Yeah, in L value, then you will calculate the reactance. Correct. So I am just
Yes, sir.
giving you the expression for L. Some people
Yes, sir,
might.
point 2 ln GMD by GMR.
Yes, correct. Very nice. Point two. What is the unit for this point two ln?
Sir, this is millihenry per kilometer.
Oh, very good. Means whatever the expression used, someone can use log expression also. Someone can use 2
Yes,
into
sir.
10 power minus s. So fixed to that. Means if I am using this 0.2, there is no need to that you also use that. If you are using this log expression, then use your own because and keep one expression remember. And if you try to remember all the expression, then you will get confused and it might get you may get wrong answer in exam.
Yes, sir.
I
Sir,
think
here GMD is 1 meter, right?
no. Yeah, GMD if you calculate it will come as 1 meter. Yes.
Sir, if in this question, if negative sequence reactance is asked to find, then
O- Okay. So this part I think this is for just confusing the students. I think they will not ask negative sequence reactance because in
so
trans.
if it is been asked, then like sir, GATE is what kind of examination it is.
Yeah, yeah, correct. This is a very nice question, I think. Uh, so positive sequence reactance it is asked, but I think for a overhead transmission line, we will see this how we can means
So, sir,
positive negative.
they may give like different datas, and they may ask like they may twist the question also, and they do it, sir.
Yeah,
Generally,
correct.
they
That's why
do it.
we are solving in a previous year problem because
Okay.
they play with the like they will not ask the similar copycat question of whatever asked in previous year. They
Yes,
will
sir.
just
Yes.
do the new question.
Yes, sir. Yes, sir.
So for negative sequence reactance, I think
Like what concept it we must focus into. If negative sequence reactance, like if this question is changed a little bit, like in that way, sir, I'm asking. I'm not
yeah.
asking another. Yes, sir.
So that right now I have not means gone through what will be the consequences.
Okay, sir. I will
Because,
mail you, sir, and if you
to be no
get
no no
something.
that to be honest because uh, but if it is asked then I will discuss in this symmetrical components theory and I will just try to cover in the next session.
Okay, sir.
Okay.
Sir, I will mail you also, sir, on your.
Yeah.
Uh,
No. Yeah. Thank you.
okay, sir.
Miss, if you see previous problems, there are 3 or 4 questions on this sequence reactance. Means
Yes,
they are
sir.
they are asking about reactance, but always they are mentioning positive sequence. I think they
Yes,
just
yes,
want
sir.
to.
I have seen that, sir.
And they just want to means like people think like this is very hard, but you simply need to find this reactance.
Mm. Okay, sir.
GMR is R dash, so R dash is given as 0.01 meter. So GMD, how you will calculate GMD will be distance between all the conductors DAB, DBC, DCA, and whatever the number of quantities you've taken inside, then we divide 1 divided by 3, take the root of that. So all magnitudes are 1, so 1 per power 1 divided by 3, it will be 1 meter. and this problem is from GATE 2017.
But sir, generally they are given so long sentence.
Yeah, so but in power system you just read once, because if you see in the protection part they are always asked this circuit breaker relays mostly they ask about relay positioning, something like that. So in that question is very long, but you will get answer just by analyzing the just by analyzing the circuit. So in power system questions
Okay,
are
yes, sir.
usually long. So don't
Sir,
afraid from the.
sir, can you take some classes also regarding the concepts?
Yeah, if means time is less because we have to cover whole means this session in 2 months, means for power
So that's
system
what I'm asking, sir. Like one day you take the class, like the concept, and the next day you take that what the
problems.
yeah, problems. In that way, if it is done, sir, then I think it is better, sir.
Yeah, I think that will be good. So next session we will cover the theories, and then after that we will solve problems on that theory part. Okay.
Okay, sir. Okay.
Yes, sir.
In theory part we will not go through the derivation, just we will recapitulate the things.
Yes, yes, sir. That will be enough, sir.
Sir, I got 0.289 ohm per kilometer.
Yes, correct. So other one also just try to solve this. L value will come as 0.9 to 10 power minus 3 Henry per kilometer. So XL will be 2 pi FL 100 pi into 0.92 into 10 power minus 3 ohm per kilometer. So this will be 0.289 ohm per kilometer. This is the answer. So correct answer is 0.289. And all of you, just I'm suggesting that all of you join one test series. Whatever test series you feel good, that you should join.
Sir, from where we have to join test series?
So this is the national portal, so I cannot tell the any name, but whatever whatever your friends means, whatever circle you have, you think that is good, so you can join that session. You can join that one.
Yes, sir.
And right now we just approach the subjective part, subjective means like 45 minutes, 90 minutes test series, and at the end from the December, January, that will be the you go for whole test series, means mock test type. So let us see the next problem, problem number 4. Deepak, it is correct, 0.0289. So this part is also from inductance calculation. So in this question, the question is a single phase transmission line has two conductors each of 10 millimeter radius. These are fixed at a center distance of 1 meter in horizontal plane. This is now converted to a three phase transmission line by introducing a third conductor of the same radius. And this conductor is fixed at an equal distance d from the two single phase conductors, and the three phase line is fully transposed. The positive sequence inductance per phase of the three-phase system is to be 5% more than that of the inductance per conductor of the single-phase system. So the distance d in meters is so the first case what we are having single phase transmission line, and this is converted to three phase transmission line. So this one is radius is 10 millimeter, and the distance between conductors is 1 meter. And so we know we can write this inductance for single phase transmission line 0.2 ln d divided by r dash millihenry per kilometer. In L single phase will be 0.2 into ln d value is 1, r is 0.77, r dash is 0.7788.1.001. So millihenry per kilometer, and this will be 0.97 millihenry per kilometer. And second case is it is converted to three phase transmission line. So all are equidistant. So distance is 1 meter. All are equal distance. No, sorry. The first 1 meter means as usual, and the third conductor is placed at d distance. At d distance, and radius is for all the conductors is 10 milli. So if you find for this part, you need to calculate first GMD. And GMD will be 1 for first. We first calculate for individual conductor. Like this one is for calculating for first meters, and it is 1 meter from second conductor and d distance from the second conductor. So 1 into d for half into half, 1 into d half, 1 into d half, and power 1 power 3, 1 divided by 3. So GMD will be d
Sir, for
half.
third conductor, it will be d into d.
What? It will be ds. Sorry, yes, yes. This will be d into d. So it will be d square. It will be d square 1 power 3. So d power 2 divided by 3 will be GMD. So L3 phase will be 0.2 ln GMD divided by GMR. D power 2 by 3. GMR is 0. So guys, 1 minute. Wait. So just what you need, you don't need solve whole for a single phase because some expression will be cut. So equate both part. It is given that inductance of three-phase transmission line is 5% more. So it's equal to 1.05 L into single phase. So if you do this, then you will get L for three phase ln divided 0.7788 into 0.001. 0.001, and this is 1.05 ln divided by 0.7788 into 0.01. So use the this logarithm use this logarithm what logarithm concept that ln x plus ln y is equal to ln xy. So bifurcate this ln d power 2 by 3 and ln 1 divided by 0.778 into 0.01. By doing that, you will get ln d power 2 by 3 divided by 0.05 ln 1 divided by 0.7. So by simplifying this, you will get d value as 1.439 meter. So approximately 1.4 meter is the answer. So this is little bit not much lengthy, but calculation should be clear.
Sir, can you explain a little about it?
So in this question, it is asked that a single phase transmission line is given, and for the it is now converted to three phase. It is now converted to three phase, and in the third conductor is placed at a distance d from both the conductors. So in this question, inductance for the three phase system is 5% of the single phase system. So just you need to equate the expression and you will get the answer. In this question, not that much concept. If you know the inductance value, then you can easily find. So we have less time, so we will cover two more questions more. So let us. Yes, 0.28. So let us see the fifth number. Fifth problem is that a composite conductor consists of three conductors of radius r each. The conductors are arranged as shown below. The geometric mean radius in centimeter of the composite conductor is given in kr. The value of k is. So how we will calculate the GMR? So we will write for each conductor and then just multiply all of them. So GMR will be GMR for this. Suppose this one is the first conductor and second, third. So GMR1 multiplied by GMR2 then multiplied by GMR3. So GM, if you see all conductors are having symmetrical spacing. So if conductors having symmetrical spacing, then all having the same GMR. Unlike the previous one question, in that question unsymmetrical spacing in there. So for for all the conductors we are not having the same GMR. So we can write it as all are equal. So GMR cube 1 divided by 3. Symmetrical spacing, that means what? That means GMR1 is equal to GMR2 is equal to GMR3. So whole GMR will be GMR1. So if we calculate GMR for one conductor, then you will get the whole composite conductor GMR. So GMR will be GMR1, and that will be GMR1 will be for first radius will be R dash into 3R into 3R power 1 divided by 3. R dash will be 0.7788 and radius is R into 3R into 3R power 1 divided by 3. So we will get 0.7788 into 9 R cube. So R cube will be cancel out with R. So R will come out. So we will get 1.913 R. So K value is 1.913. Is there any relation with centimeter? No relation, but they have given the question to just make confusion between the student. Type your answer in the chat box. Whoever are getting the answer, they have to type in the chat box so that I can verify. So in each session we are going to solve at least 5 problems, and if we having time, then we will go to see the next problem. I think all of you are able to understand this problem. So let us move to the next part, that is the last problem for today's session, question number 6. And this previous problem is from GATE 2015. And this question number 6 is from GATE 2023, the last year problem. So just to analyze this circuit and you will get the answer. In this problem, a balanced delta connected load is consisting of a series connection of one resistor R is equal to 15 ohm and a capacitor is having 212.21 microfarad in each phase, is connected to three phase 50 Hz 415 volt supply terminals through a line having inductance of L is equal to 31.83 milli per Hz as shown in the figure. Consider the change in supply terminal voltage with loading to negligible and the magnitude of the voltage across the terminal VAB in volts each. So you need to find this line to line voltage VAB, and it should be in integer.
Sir, here VAB is nothing but voltage
Voltage,
across R and C.
yeah. VAB, how? Yes, voltage across R and C. Yes, correct. You can approach that way also, but most simple way that you convert this delta system into a star system, and then you just make the per phase equivalent circuit. That will be simpler one. So first you will find this Z delta means load. Z delta is given as R minus J divided by omega C. R is given as 15 minus J 2 pi to 50, and C value is 212.21 10 power minus 6. So it will be come approximately at 15 minus J 15 ohm Z delta. And if you convert this Z delta system to Z star 1, and so, and we will also calculate this XL value. XL will be J into 2 pi into 50 into 31.783 into 10 power minus 3 ohm is equal to J 10 ohm. So the system will be look like in delta system.
Sir, it is already in delta connection, right?
Yeah, delta. So I'm writing the just means you can easily get it delta connection, but many person confuse that delta configuration is like that. So I'm writing the values only here. J10, 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 and all the values are 15 minus J15 ohm. So if you convert this delta system to star system, how will you make this? So XL value will be same J10, J10, but this value will be same 5 minus J5. So Z star will be Z delta divided by 3. So 5 minus J5 ohm. So now we will make this per phase equivalent circuit in this new slide. Per phase equivalent circuit. For delta system, you cannot convert directly into per phase equivalent circuit, but for a star system, you directly convert this into per phase equivalent circuit. this is J10 and 5 ohm minus J5 ohm. So the per phase voltage will be 415 divided by root 3 at the angle of 0 volt. So what will be the VA? VA will be here. This apply this voltage division rule. VA will be VSA. Suppose this one is VSA. VSA, and we are having assume this as we assume this as Z star. So VA will be VSA into Z star XL plus ZY. XL is J10. So put all these values. VSA will be 239.6 into Z star is 5 minus J5, and then XL plus ZY will be 5 plus J5. So 239.6, 5 root 2 minus 45 degree, and 5 plus J5, 5 root 2 at the angle of 45 degree. So it will be give VA is equal to 239.6 at the angle of minus 90 degree volt. So this is balance. This is balance system. So how we will get VV? Simply the sorry, magnitude will be same and the angle will change by 120 degree. Since the system is balanced. So yes,
Sir, this value you are currently calculating or you have already calculated it?
no, I have already calculated. So I am seeing that because I just gone through one solution.
Okay, sir.
So BA will be what? BA will be, if you find this magnitude, then BA will be 239.6 into root 3, the same as the source voltage, 414 volt. And you can also write VC 239.6 minus 120 plus 10 degree, then it will become 30 degree. 415 volt will be answer. So answer will be the 400.
Sir, can you show the question again?
Yes, sure. Yes. So is there any doubt? If so, if you don't have any doubt, then we will close our session. For this part, the answer will be 415 volt.
Hello.
Yes.
Sir,
Yes,
I
sir.
am able to understanding this problem, but sir, when I cal I solve any problem, then I I could not able to solve them, sir.
No, no, means like if you approach any problem, then first time you may take half hour, you may take 1 hour. But if you practice more and more, then only will get the speed. So speed, you are struggling right now because you have not gone through so many problems. If you gone through so many problems, then you can easily means by seeing that question that how can you approach, how you will get the answer, you can easily identify. The problem that you have not approached so many problems, that's why you are struggling, means you are not getting the bay. Okay, so that's why I'm telling that
Yes,
just
sir.
means don't read too much theory. This is my personal suggestion. If you read too much theory, that will not good for a GATE exam. Yes, that will good for interview and all that, that is true, but reading theory does not make the give the good marks in GATE exam. Approaching means going through the test series and solving the questions more and more, that will be uh, just find up and boost your preparation. Okay, Deepak.
Yes, sir. Yes, sir.
Yes, so
Sir, I wanted to confirm your
yeah,
approach to this question once.
yeah,
Sir, you first uh, converted the delta to Y because we are finding only the voltage across AB.
yeah.
And then after we have the equivalent conversion,
Hmm.
then we can find the per phase equivalent circuit.
Yeah. So
And through
now
that, we are
suppose
able to find.
means I think what your question is, you may think that we can find it through delta express means equivalent circuit is also. Means from delta circuit you can also get it that. But what you need to do, you need to apply more KCL KVL. So from that that is also fine. Means in delta circuit, here in this delta circuit, I think that is your question. Hello.
I'm sorry, sir, but I was just confirming your approach because I was a bit late.
Okay, this ABC, this is ABC. So you can also find, this VSA, VSB. This is source side voltage. So you know this VSA. So you need to just define this. This is IA line current.
No,
And
sir. We know VAB, right? 415 volt.
yeah, VSA, VSB, So sorry, IA, IB, IC. अरे यार. So this is IB and this is IC. So writing this VSA, and what will be this current? If IA, IB, IC defined, then this will be IA minus IB. So writing KVL across this expression delta in delta system only, you can also get the answer. But whatever is that, if you simplify into a star system, then you can get the per phase system. So by analyzing that, you can easily get the answer. That is more simplified way. But if you apply this KVL in GATE exam, and a difficult part is that all the expression in phasor. So in KVL you need to simplify and write in the form of uh, this J expression. So that might be take more time. Okay.
Yes, sir.
So approach also matters, but if you having concepts clear, then you apply any you apply any method, you will get the answer. Sometimes it may be late. Hello.
Yes, sir.
Yeah. Yeah. Hello. Yes, Deepak.
Yes, sir. Your voice is clear.
Okay. So now we are closing this session, and in the next session we will first cover the some parts, some theory parts. I mean some like short notes We will short recap on the theory portion, and we will in the after that we will solve problems in the upcoming session.
Yes, sir.
Okay, all right.
Yes,
Thank
sir.
you all.
Hello.
Yes, thank you
So it's on
everyone.
Monday, right?
Yeah, yeah.
Sir, could you please share with us notes, short notes on this topic?
Yeah, at the end I will share, but right now just go through the session and try to solve the problems.
Yes, sir.
Thank you, sir.
Any other doubt? Okay, thank you all.
Thank you, sir.
Bye bye.
Bye, sir.